All right, everybody, let's give a round of applause for Jeremy Numay, and we're going to have our second talker now. Thank you.
Yeah. Hi, everyone. So I hope I will have as much love as you gave to David before on this topic as well. So multicast ABR technology unleashed. I will try to explain what is the technology. Maybe some of you know this already. I will go into detail about the technology, but to give you feedback as well, what is the technology already deployed in with some customers that we have on our side. So why we do that and why we develop this technology? I mean, I'm talking about but it's a technology that Broadpeak developed. It's now a standard, a part of DBB, Cable Labs, SCT as well was involved in the past on this technology. So the first goal of this technology is to solve some issues that we have on live peak events on ABR streaming. So here you have two examples why we have to come with a solution for live events. This is just an example on the left here about a Formula One race with some streaming from the Netherlands. That you see each time there is an event between the race, so the training, the qualification, and then the race at the end, there is a peak of traffic on the network. The peak of traffic, so we can see it compared to the average value of the live event. So for the race, it was 25% more than the average traffic. So it's not a lot, but it's already a big peak. If we compare on the right with some values that we have from an operator in France on the Champions League final, so the rate was the peak rate was much more than the average value, 100%. So this is what we are trying to solve with multicast ABR, is to erase this peak of traffic. Instead of using unicast, we can use some multicast technology. So what is the technology? Not in detail. I will try to stay high level for this audience, even, and I'm sure you are all technicals here. So there are two main components in this technology. The first one is what we call the sender in the DVB standard, and what we call the receiver is as well in the DVB standard. So this sender is going to get the stream from the origin, whatever the origin. It has to be ABR origin. It's either dash or HLS. This convert this HLS and dash into multicast. We stream it up to the end user that convert it back into unicast for the player. So what is interesting with the technology, that it doesn't change anything about your origin. You have an origin today in place. It doesn't change anything. It's still HLS with the same encryption, it's dash with the same encryption. Same on the other side, so we have the application that receive HLS or dash, and it's the same application. So there is no change on the overall end-to-end delivery, except that in the middle, we are using multicast. What is interesting with the technology? So we're talking about live events. Live events, it's once per week, two times per week, or even once per year for the Super Bowl. So we don't need to use multicast all the time. So this is one of the benefits of this kind of solution, that it could be hybrid. Some live could be delivered using unicast, some live could be delivered using multicast. And we can change it over time. If we have to change the live in multicast, we can change the live in multicast, and the other way around. So this is the big principle of the technology. Again, two components, the sender and the receiver. So if we zoom in a little bit on the receiver, so on the receiver on the home side, so there are three main pieces that we have in this receiver. The main one is the multicast receiver. So we have to receive multicast, so we have to be compliant with multicast. Another one, it's we consider this agent or software that we have in a home as a cache server. This is, well, on our side we call it nano CDN. It's a small CDN that we put in a home. It's a cache server, a real cache server. So we can cache content, we can cache chunk as any cache server that we have on the CDN. The other aspect is the request router. So this one, we need to have it for this flexibility and this hybrid approach, whatever it's unicast or multicast. So we need to select which kind of stream that we have to use. So again, three components, three main features that we have part of this software. This software, it's typically in the home, and we will see after. It could be on a gateway, as we just seen, or it could be on a set-top box as well. We need some place in the home to get this multicast and give it to the application as a unicast stream. So it could be the gateway, it could be the set-top box, it could be directly inside the application as well, or the provider. So some use cases. This is becoming interesting. Why we do that and how this technology is deployed by a customer. So there are two main use cases that we see today. The first one is pay TV operator. That today they are using IPTV or broadcast on cable network. They have a service, TV service. They want to do the migration to HTTP service. For the benefits that we all know, ABR technology to switch bitrate when we need to switch bitrate. Some other services that they don't have on IPTV or broadcast technology, that timesheet buffer, start over TV, catch up TV. All of this is not always available on IPTV or cable network, so they want to do this migration for broadcast technology to HTTP technology. So this is one use case that we're seeing today. The next one, it's what we call open MABR. You get the name here, it's open caching, but for content providers, and we are using multicast instead of unicast. For those who don't know open caching, it's a way to offer some CDN capacity inside some ISPs for content providers. So ISPs, they offer their CDN, their network, for content providers to deploy their content inside the ISP. So on top of offering some capacity of the network, we offer the multicast capabilities for them. So we will see how we can do that and how do they do that on their side. So if we focus a little bit on why they do that. So if we come back on the pay TV use case, so today pay TV operators, they need kind of two head-end, one head-end for their broadcast solution. It's TS typically today, and they need an OTT system to reach the new devices, which is not really new anymore, but still they have these two head-end and these two encryption that they are using today. So it's kind of painful to maintain, so they want to get rid of at least one of them, and this is why they are doing this migration from broadcast IPTV to full HTTP. There is a big issue for them because today they have the scalability of the multicast of the broadcast. So they are a little bit scared to do this move to full HTTP because the live today on their network is delivered using multicast or broadcast. If they move everything in HTTP, it's going to be unicast. So they don't really have any solution, but they have to do it. So Multicast ABR can come as an enabler for them to do this migration. They don't have to be scared about this live delivery because they can do the same. They can use the same multicast technology that they are using today for their TS legacy delivery. So there is one single add-on. If we move to Multicast ABR, it's only ABR add-on to deliver HLS and Dash. Same encryption is going to be DRM, so they don't need CAS and DRM. It's going to be just only DRM. And on the network, they can use everything they deployed. With a multicast network, they can use the same multicast network to deliver ABR streaming instead of just TS streaming. So this is one use case that we are seeing today. This migration from for pay TV operators that migrate their legacy multicast broadcast technology into full HTTP streaming using Multicast ABR. The next one is some operator, some content providers that they need to scale the distribution. So today they are using CDNs as a service to distribute content to the end user. In some countries, it could be an issue because CDNs, they cannot scale for live events in some countries. I'm not talking about the US. CDNs are very big, and pipe are very big as well in the US, so it may be not an issue in the US. But in Europe, networks are pretty small, because mainly in Europe, they are using IPTV and multicast for live. So their network is not well sized as it could be here in the US for live events outside of their network. So this is why they need this kind of a technology as an enabler to stream their live event to the end user. So it's kind of the open caching-like solution. So ISPs, they open their network and their capacity to offer some multicast capabilities to content providers to stream their content inside their network. So it's a win-win situation. Content providers, so they can deliver with a better quality up to the end user, and they can reduce the cost as well. There is less CDN involved in that situation because the last mile will be multicast up to the end user. On the ISP side, it's interesting for them as well because they can optimize this kind of stream that typically they have no control of this stream. If we take the example here about Prime Video with the Thursday Night Football, that operator like Comcast Charter, they have no control of this traffic on their network, but they have to stream to the end user with the network. So it's kind of an issue for them in Europe. So they try to work together to make the quality to make sure that the quality of the stream will be the best for the end user. So this is the story of Telecom Italia and DAZN that we use in Europe. I'm talking about Europe because Europe, again, some networks there, it's the networks are not scaled as it is here in the US. So it was not ready for Telecom Italia was not ready to receive all this DAZN stream on their network as a live peak event. So this is why they work with DAZN work with Telecom Italia to find a solution to deploy this live event. As the story saw, DAZN won the right for the Serie A in Italy. So the Serie A is soccer in Italy. It's kind of a religion there. And part of the contract, the government put something that if it's not working in terms of quality, they have to give back the right to Sky, who was the previous owner of the rights. So DAZN had to find a good solution, technology, to deliver good quality to the end user. So this is when we decided as a group altogether to use Multicast ABR on the Telecom Italia network to scale the live of DAZN inside the Telecom Italia network. So we will see after with numbers how we can do that and what was the result. But DAZN scale not only in Telecom Italia, but we're using other ISPs in Europe to stream all the DAZN content in some ISPs. So if we come with some numbers about what is the benefit for operators to use Multicast ABR. On traffic savings. So we were about to save 33 petabytes using Multicast. This is an example with 27 million sessions over 48 hours. This is the traffic that we can save using Multicast ABR. If all this traffic would have been unicast, it could have been a big bills on CDNs. So this is one of the benefits of Multicast ABR. First is to save some CDN cost, but also to improve the quality of the network, of the streaming, sorry. Another number that we can share here for the same example. So we stream 85% of the traffic using Multicast. So this is pretty interesting. What is interesting is typically we say that nobody is watching live at the same time, so we need to still stream unicast, which is true. Here we can see the breakdown about when we have to use unicast. So there are three main reasons why we still need to use unicast even if we have Multicast ABR technology. The first one is time shift. So timeshift session, if you want to watch your live in the past, so it's not really the live event that you are watching, but you are a little bit in the past. So we are streaming in multicast. So multicast, is when it's done, it's done. We don't have the stream anymore. So we have to switch the session in unicast. What we realize for live events, timeshift session is not a big feature. A lot of people want to watch live in live, not in the past. You don't want to hear your neighbor before you watch something. Even with social networks now, even except if you want to get disconnected completely during an event, it's very hard not to hear about the result of a game. So you have to watch the live in event, in live. The other reason is, of unicast traffic, it's when we start the session, we start in unicast all the sessions that we start. This is one of the reasons we have the same startup time, whatever we are in multicast ABR or in unicast. So we start the session in unicast. The third reason is, so multicast is UDP traffic. UDP traffic, you could have some packet lost on the network. So we have to retransmit those UDP packets using TCP. So this is the third reason why we cannot reach 100% of multicast, is because you have some timeshift session. We need to start the session in unicast, and we have some packet lost. But 80% of traffic using multicast, it's a lot of saving for the ISPs. Multicast efficiency for open multicast ABR use case. So this is a dozen use case. So you see the average traffic. It's kind of nothing. As soon as there is an event, there is a big peak of traffic. So same, it's 80% saved using multicast traffic. But now the operators, they don't really care about the peak of traffic. So this is a big benefit of multicast. Whatever the traffic, whatever the number of sessions that you will have on your network, it's going to be the same consumption on your network because it's multicast. Live DAZN, they are streaming like an event-based, so it's not a 24-channel live streaming that they have. It's really event-based, and you can see that on the graph here. As soon as there is a boxing game or a soccer game, you will see the traffic increasing a lot. But again, it's multicast, so there is no issue on the network. Other metrics that we typically use in our industry, zapping time, it's a big metric, big KPI that we are typically using in our industry to measure the quality of the stream. So here an example over 30 million sessions. So we have an average startup time which is around 1.2 seconds, which is, and 50 of them was below 1 second in terms of startup time. So why we can reach that? We start all the session in unicast and then we switch in multicast. So there is no difference between starting a session in traditional ABR streaming and multicast ABR streaming. And maybe another, some other numbers as well, which is not coming from us, but from the industry, from Conviva. Conviva, they did an analysis on what is the traffic with unicast and what is the traffic with multicast ABR on the DAZN streaming. So this has been done in Spain, on Orange Spain, on two different traffic, unicast traffic and multicast traffic, and they measure the improvement between unicast and multicast. So here we're not considering the scalability of multicast, but more the quality of the stream. How we can improve the quality of the stream with multicast ABR. So going back on the video start failure. So this is mainly due because we don't need to, the CDN can serve to something else. It doesn't need to serve all the unicast traffic. So we can use the CDN only to start the session. So this is why there is a big improvement here. 90% of the start failure was improved. So it was a big improvement for DAZN. Another improvement is about rebuffering rate. So we improve by 76% the rebuffering aspect unicast compared to multicast. Another one is it's about failure after we started the session. So there is less and less failure because again we are using multicast. This is a guaranteed stream. It's not the best for streaming. Yes.
Can I ask a question in the middle?
Sure. Sure. Yeah.
It says on MABR capable devices, but in a previous slide, you had your gateways and whatnot, and then it would work on any device, right? Any HLS dash capable device could receive that. So what does MABR capable device mean in this case?
It means that we don't consider all the session which is not MABR. Because here...
Okay, so MABR, with respect to MABR sessions.
MABR sessions.
Yeah, okay,
yeah.
Thank you.
Yeah. And this is a hybrid solution as well. The technology we have to deploy an agent, which is on the gateway. We cannot deploy agent on all the gateway of all the ISPs. This is one of the reasons that it's very hard to have 100% multicast ABR sessions because we cannot deploy this software in all the gateways deployed in the field. Another improvement here, which is, I would say, negligible for now, but if we go with a bit higher bit rate, it could be a big improvement. Right now, we can improve the average bit rate, reaching the highest later in the ABR streaming, 11%. If we consider 4K here, I'm sure we can go higher than 11%, because higher the bit rate will be, the higher the consumption you will have on the network and on the CDN. So this is one kind of a side benefit of multicast ABR as well. It's we don't really care about the bit rate itself, as soon as we can deliver it in multicast. Yeah. So if we talk about takeaways here on this presentation, so average we can serve the session using around 80% of the session can be served using multicast. For the reasons that we just mentioned, that we cannot serve all the sessions using multicast, some gateways where we cannot put some agent in the home, some traffics that we cannot serve using multicast, but average we can serve 85% of session using multicast. Another big benefit, and this is one of the reasons multicast ABR has been developed, and this is now the standard as well, that we want to erase the peak of traffic. So we don't care about the peak of traffic. So we come back to this broadcast or multicast technologies that we used to have inside the operator. And we improve the quality of streaming. This is, again, a side effect. The first goal for the industry was to erase this live peak traffic, but the side effects that we can improve the quality of streaming. Yeah. Do you have any question? Another question? Yeah, sure.
Sorry. So I think you said that it's hard to get your agent on all the gateways. Can you explain what's hard about that? Why can't you?
So on a gateway, so we need some resources. So we are going to run a binary on the gateway that computes the multicast and deliver it in unicast. So we need RAM on the gateway to do that. So I would say gateways older than 5-6 years, it's very hard to have some compute power and RAM available to do this process.
There's legacy devices that just don't have the compute or memory or whatever.
Yeah, okay. That's it. This is why we, sorry, follow-up question?
Yeah, and then the ISPs in the I think in the open model that you talk about, the ISPs, educate me. They natively support multicast, so there's no problem there at all. It's just if the gateway can support the agent, you're good.
We're good, yeah. So we see some deployment on the gateways, but we can use the set-top box as well. Some operators, they know that they have 10, 15 different gateways. So for them, it's going to be hard to put an agent on the gateway. So we consider the set-top box in that case, which is Android. So we have an agent which is compliant with Android, so it's easier for us and for them to install this agent on the set-top box directly. And we can serve all the devices in the home same way.
Yeah, and so with those kind of numbers, which is very impressive, I think it's very cool technology. What keeps you from just getting more rapid adoption?
I would say operators, they don't feel the pain of OTT today. Not yet. They can feel it now, but it's not a big struggle for them. It's coming. It's coming more and more. In Europe, I guess they're at that point that they need to find a solution. Maybe not yet in the US, because networks are so big that they don't feel the pain of this OTT traffic which is coming. In Europe, they were using all IPTV multicast, so live delivery was multicast only. So the network are not really ready to absorb this kind of traffic which is HTTP today. This is why they need to find a solution. So they have two solutions. They can use a brute force approach and scale the network, new switches, routers, and everything. Or they can find another solution to deliver video. It's two different approaches.
And are CDN providers kind of a key part of your ecosystem to get adoption, or are you're just kind of agnostic that it doesn't matter what the CDN is and you work with the ISP?
It's a good question. We would love to work with them actually, as Broadpeak. I mean, we don't want to fight against them. We want to work with them. Because we think it's going to be beneficial for them and for us. I mean, the quality will be good for the CDN. For us, it will be good because we can sell our technology. For the ISP, they can have multicast, they can optimize everything in their network. So I guess it's a win-win situation. Yeah. Because
there's an origin, but you can still use the CDN in between you and that, right?
That is true. I mean, multicast CBR is on-prem, on-net. We still need the CDN to get the stream. So CDN, they are part of the equation, but not to scale the live.
Okay. Sorry, Mike. Sorry to interrupt. No, but I knew that. That's cool. That's cool. So, Jeremy, thanks for the presentation and those questions and answers. Couple of questions on my side. So is there an average threshold of simultaneous concurrent users at which level it becomes interesting from an economical standpoint for the ISP or the content distributor like DAZN to use multicast? Where is the switch point?
It's not really the concurrency overall. It's more the network topology, which is there. In cable network, you have some CMTS I can deliver for 500 users or just 50 users. This is where you can share the multicast and where the multicast could be beneficial for the network. In IPTV, that depends of the DSLAM as well. So it really depends of the topology of the network. Not really the concurrency overall, but what is the concurrency per, I would say, neighborhood almost.
Okay.
Yeah.
So you talked about the usage of multicast ABR for event-based streaming. So in practice, how realistic is it for an ISP to provision a new multicast channel in a service plan on the fly? How long in advance do you need to anticipate that you're going to need to use multicast ABR?
You mean if you have a multicast technology already deployed, or if you have nothing deployed?
If you have the technology deployed,
okay,
right? But suddenly there is a peak of traffic, and then you find out that, okay, now I need multicast ABR to save my life. How fast can you react?
I mean, on our side, so we can switch from unicast to multicast for the next chunk if we have to. As soon as we have the control of the session. If we don't have the control of the session, we cannot switch from unicast to multicast on the next chunk, so we have to wait for the next session. So it's per, I would say per session. When you start a session, you have to decide if you can go potentially in multicast world, or you want to stay in unicast world. This is where you will have to decide if you switch to multicast or unicast. But if we have the control of the session on the agent, we can switch dynamically from unicast to multicast or even multicast to unicast. It could be the opposite.
But you still need the ISP to allow a multicast for this particular event.
It's a configuration that we can do. Yeah.
Okay.
Yeah.
And finally, only 3 questions. So there is a lot of greening of streaming discussions in the industry, how we can be more sustainable, how we can consume less energy. So I wanted to understand, is there any numbers about how sustainable is multicast ABR compared to pure unicast streaming, let's say for 1 million concurrent users? Do we know how much energy do we save by using multicast ABR or not?
I don't have the number, but I know that we did the exercise on our side. If we consider 1 session in unicast, 1 session in multicast, multicast consume more for 1 session, for 1 million session. I don't have the number. Because multicast, you are more equipment involved, so it consumes more for 1 session. But there is a scale aspect that you are going to consume less with multicast than unicast. Yeah. Yeah.
Thanks.
Welcome.
Other questions?
Mike.
Okay. Reclaiming my time. Can we jump back to slide 17? Because I want to ask you a question about the way that this is constructed. So I don't want to be a complete nerd, but there's this idea of Maslow's hierarchy of needs, and sometimes people like to draw at the very bottom Wi-Fi. I need Wi-Fi first, and then I need water and food and shelter. And the way that you've presented this, you have these benefits that are considered so important to viewers giving up on watching something. Like, I tried to connect and it didn't work, I'll watch something else. I connected and then I got disconnected, or I'm experiencing too much rebuffering, and then you get all the way to the end and then it's a different benefit, which is I'm saving you money, or I'm barely saving you money because I'm delivering such a high quality stream that it doesn't reduce your bandwidth very much. And so it's not like the other 3. I almost think that the way that I would present this is 89% of people get the highest bitrate version of that content. And then they're all the same in terms of benefit to the viewer, in terms of benefit to the producer. And I wonder if you've built the slide for content providers or viewers, or how you're expressing these benefits.
So first, we didn't build the slide. This slide come from Dazn and Conviva. And I guess they use the metrics that they used to have. You should keep in mind that the first benefit of multicast ABR is the scalability, which is not on this graph. So we cannot see anything about the scales that we can deliver, but really the qualities that we can improve. And you're right. I mean, the first 3 metrics is not about the quality itself. It's just someone dropped the stream, so it's different. The quality that we can improve is only 11%. If it was your question, kind of. You're right. Yeah.
It makes perfect sense that it's their slide and not your slide.
Yeah.
I love it. No follow-ups.
That's always my answer. It's that guy's slide. All right, yeah, you went from 15 to 3 to 1. Anyone got, I'm just kidding. Anyone else have a question? Yes, okay.
So what is involved on the ISP side to set up the multicast? So there's all these great advantages, but what is really involved in getting it all set up to use?
So I would say, so they have multicast. Most of them, they have multicast already deployed for IPTV. Or even for cable networks, they have multicast as well. So this is already there. We don't ask for this part of the network. what we have to do, and the big lift, I would say, this agent that we have to put in the home, on the gateway or on the set-top box. This is where we have to work a lot. But at the end, all the set-top boxes or gateways are using the same chipset, whatever is coming from Broadcom, from Intel. So all of this has been done in advance. So they just use what we did with others, and they just put this agent part of the gateways. So this is a big lift that we have to do. On the head-end side is just a server that we install. It's part of the ASP, and we get the stream, like we can get the stream on the CDN, on the origin, and this is part of, I mean, this is typically a network connectivity, so there is nothing more to do here. Yeah. And then we connect to the multicast network. Yeah. And so on this slide, on this one, what I presented here is that in 4 months, we can deploy this technology inside an ISP. From nothing to production in 4 months. So when we have multicast already deployed, it could be very fast. As soon as everyone is very motivated to do it. And in that case, DAZN was really motivated because they have this contract with this agreement with the government, so they had to do something.
All right, here we go. I saw you working this out over here.
All right. Very interesting question is, has there been any thoughts of how this works with personalized ads? I mean, as the industry's moving, we're working towards like personalized ads for everybody, SSAI.
Yeah.
Obviously, in this case, you're sending a linear stream out multicast, right? So does it land on the set-top box or whatever to do the ad insertion, or how's that? Or is there plans in the software for that, or considerations?
Yeah. I will use this. It will land on this agent that we have here. So this agent will do the manipulation basically. That you have your SSCI, your media tailor, which is doing the manipulation to there. This agent is going to do the same. It's going to ask the manifest to media tailor to have this targeted manifest that we have to deliver to the client. So it's compliant. So you will receive one live, which is, I would say, the main one. And here in the home, we will get the manifest from media tailor that we are going to deliver to the agent, to the client.
Yeah, at that point, yeah. So yeah, wouldn't it be server side on that?
Yeah.
So the client would need to be making the request to that decision server. And then I have another question of my own. Yeah, totally all on my own. Back to slide 17. It talks about 500,000 hours of content viewed. Is that just in this use case with Danza, or is this overall view? Or DAZN. My apologies. DAZN. Is it really? Oh, I've been doing it wrong this whole time. But
So you learned something tonight.
yeah, thanks. I mean, well, I'm hoping to learn two things. Is this overall testing in Spain, or is this just for the single customer, maybe a single event? The 500,000 viewing hours of multicast ABR delivered.
Well, sorry, where is this number?
The third bullet point.
This one, half. It's big. I mean, so this has been done around Spain. So I don't know how many subscribers they had, but it's around 5 million probably. Yeah.
Right. Yeah. It's just, like we've got, it was 59 million concurrent viewers on Cricket. Is that right? Yeah. It just it feels like kind of a
Approximate.
Yeah, it's an approximate number. Yeah, it's maybe a little more context there. It just doesn't seem like it's been tested well if those are the numbers that are coming out.
Yeah, I mean, you should not compare what's happening here and yeah.
Okay. Yeah. All right. Okay.
Yeah.
Like that. Yeah. Yeah. Yeah, I know, right? Yeah, sorry. Like, I feel like we've been beating you up on this, which is good for all the other slides, I guess. All right.
Oh, I just found the microphone. So was this a test in Spain, or like DAZN covers like a lot of countries? Like, why not France? Why not Italy? Why not like is it?
So-
Yeah.
Yeah, I can go over the company itself. So DAZN, it's a content provider. It's from UK. So they bid on rights, mainly soccer. In the US, they are just doing boxing game. But in Europe, they are very strong on soccer. So they won in Italy. They won this year in Spain. So they deliver like Prime is doing here in the US for Thursday Night Football. They do the same for the entire league in Spain for the soccer. But they have some issues on the scalability of this live event because it's OTT only. There is no broadcast mechanism involved in Spain, in Italy. I mean, same here for Prime. I mean, there is no broadcast mechanism. It's exclusive rights on OTT. So they have the same in Spain. So we're working with them on around Spain, in Vodafone Spain as well, to deliver multicast inside these ISPs and use their streams that we can deliver using multicast to the end user.
And so does DAZN stream in France and Italy as well, or is it just to Spain for Serie A?
It's not Serie A it's La Ligue A in
La
Liga.
Liga. Okay, so it's the
different
Spanish
championship.
league in Spain.
Yeah.
Okay.
I mean, it's in Italy, in Spain, and they are getting bigger and bigger. So we hope that we are going to scale with them. Maybe in the US. We'll see. Compete with Prime, why not? This could happen. Yeah, I'm not sure they're interesting, but we'll see.
So this might be related to an earlier question, but one of the things that's always been a kind of a sticky point with multicast. So like in the early days of 2110 adoption in the industry, right? The industry moved towards multicast, and a lot of the infrastructure providers, the Cisco's and Aristas and so on, they couldn't handle scaling out to thousands, let alone tens of thousands of multicast flows for kind of on-prem 2110 networks, right? And so I'm just curious about the infrastructure of ISPs and the ability to scale out multicast. I mean, the thing is, multicast is, I think, fair to say, atypical for network providers, right? So I'm just curious about, as you've been promoting the technology and seeing adoption, what type of scale out issues have you seen with multicast? And is that a factor for what you've been working with here?
Yeah, so we consider that multicast has been deployed for IPTV. So they know how to scale. And so they are using IPTV multicast, all these operators. They do multicast today for thousands of channels already in their network. So they know how to scale it. If we use multicast ABR, that it just come not on top because we are going to replace some IPTV channel with multicast ABR channel. So it's not extra multicast that we're going to put on the network, but we're going to replace some multicast IPTV network, some multicast IPTV channel into multicast ABR channel. So I'm not aware about any issue of the multicast scaling in some operators because they know how to do multicast today already. It's not new for them. Yeah. I know that I guess there is a big religion between maybe Europe and the US. In US multicast, it's kind of a bad word. We should not talk about multicast. Everything should be unicast. I guess it will come again, I'm sure. Because unicast traffic, it's kind of, it cannot scale forever. We should find some solution to scale this unicast traffic. And multicast, it's a good technology. It's old technology, but still good technology. There is no real replacement today to replace multicast as a technology, as a transport layer to scale one-to-many. It doesn't exist, as far as I know. So it's a good technology to do one-to-many. And for live distribution, we think a good technology.
Yeah, totally agreed. I mean, that's what it's built for, right? Yeah. It's just not that common. It's just not that common of a use pattern in the IT industry, right?
True. Yeah. But again, I guess we are. Maybe I'm focusing too much on Europe. You are focusing too much in the US. But yeah, it's deployed. It's deployed a lot in Europe. Yeah, yeah.
Anyone else? Going once.
Going twice. All right, let's put our hands together for a great presentation for Jeremy. Thank you so much.